Go.
Hello, my dear students, and welcome to the Bobcat Paw here at Dumas High School. I want to do a famous demonstration for you, but one we must do outside because when we do it inside, we frequently set off the fire alarms and smoke alarms and cause a little, collateral damage when we do this demonstration. I want to show you the classic experiment of what happens when sodium is added to water. So if you look at sodium, and I have a few pieces of sodium here, it is, like most metals, a beautiful, bright, and shiny metal, but it is highly reactive. It's a group 1 metal, belongs to the alkali metals, which means it forms an alkaline solution when you mix it with water. So I have a large piece here that has some oxides or something on it. It might be chlorides in the chemical storeroom from the hydrochloric acid leaking. It should be stored completely underneath oil or kerosene, mineral oil or kerosene. And this piece was sticking out, so it has some crystalline contamination on the surface. It usually forms a quick layer of oxide. And I'm going to cut a piece of this off to show you that it's a soft metal that is easy to cut with a knife. Beautiful, shiny metal. Okay? And I don't know exactly how to deal with those crystals on the outside, so I'm going to set this all aside, and if it blows up while we're doing our experiment, we'll know here in this humid Arkansas atmosphere. I'm going to put it into a little bit of water over here behind the safety shield and continue filming. And when we do that, this sodium will react with the water, form sodium ions, extract electrons from it and give up its electrons, and it will become oxidized, and it will reduce the hydrogen to elemental hydrogen. The heat in the reaction will catch it on fire, and then at one point it will ignite the actual metal itself in a ear-shattering explosion, especially a piece as big as we are doing this time. We'll be filming behind a safety shield here in the wind. You just heard my safety shield fall over and crack, my $100 safety shield, because I don't have the supplies I need and I wasn't expecting this wind, but this wind will be good for us when we start and ignite our solution. So, luckily I have another piece of plexiglass to build a new safety shield. If you would come over here and film this while I hold it, okay? You need to be able to focus on the beaker. I'm putting water in the beaker. And then I'm going to stand behind the safety shield and also try and weight it down here with my water while I go get my sodium. And if you can focus through the safety shield and follow along with me, you will see what happens when we add sodium to water. It's giving off hydrogen gas, and this wind, it's going to ignite the hydrogen gas, and that is going to subsequently ignite the metal and explode, showering us and the ceiling with all of the water. So that is a quick demonstration of what happens when sodium meets water. And that was about a 1 centimeter cube. And what's left behind is an alkaline solution of sodium hydroxide. I'm going to try this again, only this time I've added a small amount of the pH indicator dye phenolphthalein to our sample. This time, if it turns the water alkaline, you will see the water turn pink. That's because the phenolphthalein is colorless in acid and neutral solution and a bright magenta pink in the alkaline solution. Because what we're going to do is pull the hydrogen out of the water, leaving hydroxide, OH, behind. We'll write and balance this equation in our discussion. So, right now I'm going to go cut myself another small piece of sodium and do this experiment over again and hope that this doesn't blow over again and crack. I have a little bit of paper towel to wipe up the splash of water from our last piece of sodium so that we can get a good focus on it. I'm sure you saw the camera jump. It's impossible not to jump and to have people scream when this happens. I wish you were here in person because it's a very dramatic demonstration. Okay, we are going to film this reaction. We'll start it here now at the count of 3. And again, you'll see it producing hydrogen gas. Hydrogen gas will burst into a flame, and when enough heat builds up, it may take a little longer this time because this is not as big a piece. When the heat builds up, it will ignite the sodium itself, and we will see a very dramatic, rapid conversion of sodium to sodium ions and going with the water. There you see it turned it pink. It's bubbling. It's very windy, so the hydrogen is disappearing and not really bursting into flame. The hydrogen is being blown away by the strong wind, so we're not getting the usual flame that we see. So this time it will not explode, I predict, only because we're not getting the heat from the hydrogen gas burning. Oh, there we go. And it did finally ignite and finish the reaction. So, there you see the dramatic effects of sodium. You see why we came outside to do this. And you see why I'm working behind a blast shield, wearing my safety glasses and wearing my lab coat, and my photographer is maintaining, a 6 or 10 foot distance from the actual reaction vessel itself. There's a few other tricks I'm practicing to ensure safety. One thing I would probably do is I'd enjoy the wind because it blows away any toxic fumes, the smoke, and the steam. But it's a little too windy for safety, so I'm having to hold my blast shield closer than I like. So check me on the next video. We'll discuss your lab report there. And until then, take care.